Welcome back to Bites of Pi. Today's Kickstarter will cover Lab7b, a sorted integer list. In today's lab, you're given two different classes, the int list class, int list 7b, and the run list test 7b. Now, the run list test 7b is fairly straightforward. It just creates an instance of that list class, passes in 10, it adds a couple integers, and it prints it out. Let's run it and see what happens. So we run it, and what it prints out is the list in order. We added in 100 first, then 50, then 200, then 25, and it prints it out in that order: 150, 225. Well, our goal today is to create a child class that inherits from the int list class, but it automatically sorts the list. Now, we've gone over sorting algorithms when the array already exists, but today, rather than doing a sorting algorithm, we're going to sort it as every new integer comes in. It'll automatically put it in the right place. So we don't need an algorithm to sort it. It'll already be sorted every time we add a new value. So we're going to start off, we're going to create a new sorted int list class that extends from int list 7b. So here's my class. I've created a new sorted int list 7b class, and in order for me to have this as a child of the int list 7b class, I'll need to add extends int list 7b. Now, I note right off the bat it's already flagging me, telling me there's some issue here, and that's because I haven't defined a constructor. Because int list 7b has a constructor that passes in a single parameter, and that's it. It requires that sorted int list 7b. Now, Eclipse helps me cheat, and I can just click on a button and boom, it creates one for me. But you can see how I have a new constructor, and I'm calling the super constructor and passing in that size. Now I'm letting int list do the heavy work. I don't need to have list. I don't need to put this in my constructor because I'm simply calling my parent's constructor, and it's going to do that for me. Let's take a look at int list 7b now. All it is just a fixed array list and a number of elements that'll count how many elements are in the array. Now, it starts off with 0 elements in the array, and if we take a look at the add function, first it will check to see if the number of elements in the equals the list length. That means I've hit the extent of the array, and I can't go any further. I've already taken care of that. Then what it does is it'll take whatever value I've passed in and set it to that place in the array. So the first time through, it'll be position 0. I want to add the value to position 0. Once I've done that, I'll bump up num elements to 1. Next time I call this function, it'll place the value in section 1, and so on. So you can see how this kind of works. Essentially, when I called 100, it put it in the position 0. And it bumped it up to a number of elements 1. I put in 50, it put it in the position 1, and so on. So num elements increases after I place the value, and that's it. And lastly, I go and loop and I print out the string. So it's fairly simple class. Now if we take a look, we're going to create a sorted int list class, but every time we add a new element, we want it to automatically be sorted. So what does that mean? Well, we want it to kind of behave like the add list here, but instead of just adding it like this, we want to search the array and check to make sure that we want to put this in the middle of the array where it belongs in sorted order from lowest to highest. So in here, we want to override the add method. So every time we call the add method, we're going to walk the array and place the new element where it should go. We want to override the add method. Let's implement that. Now here in Eclipse, I can do something really cheaty, and I can add. So I'm inheriting from the int list 7b, and I've created it here. Now, You don't have to use the override. Is more of a notation than anything. It tells other developers, hey, this has its parent class already has this method, so I'm not creating a new one. So it's nice to have your JUnit. You don't need to have it. So for right now, I'll just delete it. It'll automatically recreate it again. And what I want to do is I want to look at this 7b. Well, I like this. I like this little check here that the parent does. If the elements equal the length, I don't want to add anymore. I want to return early. So I like that. I'm going to add that here. There we go. I'm not going to call a super add. I'm just going to call this again. Okay. Now here comes the meat of it. I'm just going to copy this section here too, but I want to do something different. So in here, I'll want to walk through the array. So let's put in some code that'll walk through the elements of the array. So here, I'm going to create a nice little for loop. I'm going to move this up here. I'm going to create a nice little for loop where I equals 0, I is less than the number of elements, I plus plus. And I'm going to check the position here. So if value is greater than the element in I want to skip that and move on. Otherwise, I'll want to push it on down. So let's take a look at what that would look like in Excel. So here I have an array already populated, and I'm passing in a value. I'm going to loop through, and I want to check to see if the value is greater than what's in the position at the list. So starting off, if I was using this as an example, I'm passing in 75. The list at position I right here is 20. Right? So I put 20 here. And I want to do a check. So how would I do this check? I want to see if the value here is greater than, or if this is greater than this value here. Well, I'll want to probably do an if statement. Right? Anytime we want to do a check, we'll use an if statement. And I want to check to see if the value in the array, list I, so again this position right here, if that is greater than, I want to stick it in there. If it's not greater than, I'll want to leave it alone. Okay. All right. Actually, I'm going to leave this out here just so if I loop through this, I see that I is less than, it'll skip through, go to the next one, take a look at 50. Is 50 greater than the value? No, it's not greater than the value. Go to the next one. Now here at 2, I have 100. And it meets this criteria. Suddenly list at I at 100 is greater than value, which is 75. Now I want to do a couple things. The first thing I want to do is I want to hold off 100. So I'm going to let you do this work right in here. So I'll put comments. I want to store value into a temp variable. So here in the spreadsheet, I want to hold off 100. Okay, so that's the first thing I want to do. Second thing I want to do is I want to insert value over top of that list. So here I want to insert value into array. So I'll want to insert value into the array. Okay? Notice I've wiped out 100, but I have it held off here. Last thing I want to do is copy the held value back into value, because I'm going to reevaluate that again. So I'll copy that into here. So from temp back into value. Next time through the list, I have 100 in my value array. I'll check to see if position 200. List I is now 200. Is 200 greater than 100? It is. So I'll want to do the same three steps again. Store value into temp, 200. Insert value into the array. Okay, copying that in. Copy a held value back into value. So I'm copying this back into 200. Alright. Now I've reached the end of my array, 4. I'm done. So you notice my array is not complete. I still have 200, the largest value, held off in my value. That's where this comes in. We finally finish the array, finish the loop, we come out, and then we hit this line here. And we want to keep this here, so list at num elements at position 4, we want to store the value. So at this line, we'll copy something that place in value to position 4, which is 200. Lastly, when we want to increment number of elements, and we're ready to insert the new one. So here we are. The array is already sorted. We inserted the value in the middle of the array. We pushed everything down, and everything works. Lastly, to test this, you'll want to create, instead of saying int list7b, you want to say sorted int list7b, and just allow it to run. And at the end, it should look like this. If it works and it automatically sorts, the output should look something like that. Now, when you are ready to turn this in, you're only going to turn in the new class you created. You don't need to turn in either the int list7b or the run list. All you need is the sorted int list7b. This concludes Lab7b Kickstarter. Thanks for watching.